Welcome to Learning Beyond again. Today we are going to discuss on the standard structural drawings on slab and beam sections. So in the previous videos, we have seen different details regarding the beams, like simply supported beams, continuous beams, cantilever beams. And we have also seen slab and beam details for simply supported continuous slabs and cantilever slabs. So today we will see the practical structural drawing, which is a standard drawing. See, whenever I say standard drawing, that means the details are typical details. Generally, we get the details from structural consultants in the form of table, like schedule of beams with reinforcement, then schedule of slabs with reinforcements. So we need to refer the table and we need to put the steel according to the standard drawing. So today we will see how the standard drawing is used on site and what are the typical detail types. So this is the example of structural standard drawing we get from the structural consultants. This session is useful for structural engineers also, and it is also useful for site engineers also. So those who work on site or work in office, it is useful for everybody. So if you look at this structural drawing, whatever we get, then see this left side is containing the beam details. So here it is a simply supported, then it is a fixed beam, continuous beam, cantilever beams, and stirrups details in the beams. In the right side, you can see this is a continuous slab, then simply supported slab and cantilever slab. Then there is a development length or lap length table here, and there are structural notes over here. And this is a title block of the structural drawing, where there is a name of the company, then see a title of this drawing, like standard drawing for beams and slabs, then drawing number, drawing name, and everything is written here in the title block. So this is the general content of any structural drawing. So we will see in detail again. See, this is nothing but a summary of our previous sessions, whatever we learned. So let's go to the first simple part is the simply supported beam, which we have seen. And this beam is having these reinforcement details. So there is a bar E, which is full bar, you can see here, and there is a L to this bottom bar. We know that there is a bend, say tension at the bottom due to bending moment. And then this top bar G is full bar, you can see, and we have not done any L over here because this is a simply supported end, because this is a simply supported beam detail. This is top G bar is anchor bar because this is in compression zone. So we will only provide this for stirrup anchoring. So to hold the stirrups, we will provide this. So this is your anchor bar. In upcoming session also, we will see how to use it using the table also. So this is anchor bar. Then this is total full bar E, and this E, see, and F bar is there, which is a curtail bar. So see, sometimes structural engineer will give provide 3 bars at the bottom. So 2 bars, let's say 2 T12 will be full, and 1 T12 will be curtail. So this 2 T12 bar are nothing but these E bars, and this curtail bar is nothing but F bar. So F plus E will be 3 T12. So total will be 3 T12. So this is the detail, simply supported beam detail, and the curtailment has to be at a distance 0.1 L1 from the face of this beam. So this is a support, actually beam is a support. And again 0.1 L1 for simply supported. So this is the simply supported beam detail. Now whenever we go for the fixed beam, so in totality the detail is same. The only difference is that due to fixed beam we get negative moment here. See, I think all of you know. I will show this here like this. So we get negative moment, and that's why we provide additional steel over this point, extra over support, which is nothing but H bar. So this H bar is from here to here, and we provide EL also because there has to be development length due to fixed end moment. So this moment has to be transferred into the columns. So this distance will be LD, and this G bar is nothing but anchor bar, minimum steel we can say, to hold the stirrups. At this zone, there is a H plus G reinforcement. And what is the length of this bar? From face of the column, it is 0.25 L1. L1 is distance between the face of the columns. So inside the clear distance, we can say L1. Again, on the right side also same thing, 0.25 L1. At the bottom E is full bar, so minimum 2 bar generally we provide, and F is again curtail bar, similar to simply supported beam. So the only difference is that we have extra support bars, which are L at a distance LD from this inside face of the column till the bottom of this bar is LD. What are the LD values? I will show you. So this LD is nothing but development length, and generally it is given in the drawing. So development length, how much should be the LD value? So it depends on the grade of the concrete and steel grade. Let's say we are having Fe 500 and M20 grade of concrete. Then the development length is 60 times diameter of the bar. For example, let's say we have a 12 mm bar. I have shown this to. See, if it is a 12 mm bar, then 12 into 60, because it is a 65. 720 mm will be the LD. Okay. If the bar diameter is, let's say, 20 mm, then 20 into 60 will be 1200 mm. These are the LD values you should consider for this drawing. So this is a fixed beam detail. Now continuous beam also, continuous beam. Same, it is fixed. At the fixed end, it is, let's assume this is a fixed end. So we will provide this at see this H bar here with LD like this. The distance is 0.25 L1 for this. Then as it is a end column, we will provide this at curtailment at 0.1 L1. Now again same here, but this is a mid column, mid support we can say. So it is a 0.15 L1 for this case curtailment. Actually top over support bars are same, 0.25 L1, 0.25 L2 here like this. So similar to that. So if you look at the bending moment diagram, then it will be something like this. We have already seen that in our previous sessions. Let me again repeat this like this. So this is the bending moment diagram for this. Then yes, fixed beam, continuous beam. So these are the details. See, you need to check whenever you go for checking the reinforcement on site, then you must follow these details. So you should know all these L1 dimensions. You should know what is LD given in the drawing as per the diameter. So each and every point is very much important. Now let's see the cantilever beam is also, we know that bending moment is like this. Let me show this. The bending moment is something like this. It will be let's say this is a fixed end and this will be cantilever moment. So this G bar will be for this red color moment, and this top bar is in tension. So this is your main steel and it has to go in the back beam, this beam. And what is the distance from this point to this point is L2, which is nothing but this, or LD, whichever is greater. So that is the, we can say, curtailment of this bar. So you need to anchor this cantilever top bars in the back beam. For other this fixed beam, it is same as fixed beam. There will be G bar, full anchor bar, H, and 0.25 L1 is the distance for this, and the LD is the development length from here to here. So how much should be the L? So this is the dimension. All other things are same, only this is the key point. So this top bars and this bottom bar is an anchor bar because there is a compression at the bottom in cantilever beams. Now regarding the stirrup details in beams, there is a close spacing near the supports because shear force is maximum near the support. So at a distance 2D from the face of the column, we will have a closer spacing. For example, let's say this is the C part. So for example, let's say T8 at 100 will be the spacing near the support in the 2D zone, and which is nothing but C bar. And let's say D is having loose spacing. So let's say T8 at 200 it is given in the structural drawings, schedule of beams. So this is the D bar and this is the C bar. Similarly for all other beams also. So this is the typical details for stirrups. Now this was the details for the beams. And we have seen, so you can see here in the drawing, the grade of the concrete is M20 and steel grade given is Fe500. So depending on the different projects, the grades may be different for steel and concrete. Nowadays, generally, we are using Fe500. So this is the standard practice. Fe415 is now generally not used. And see, for this problem, we are using M20 grade. So this will be our LD or development length values. So development length or lap length, they generally are same as far as the numbers are concerned, these numbers. So development length is something that whenever the force in the reinforcement is transferred into the concrete, and lap length is force is transferred into the steel. So let's say this is a lap. So these are the 2 bars and lapped. So this length we call it as a lap length. Generally we use it in beams or columns. And development length means whenever we transfer the force from steel to concrete. So here you can see. So this L bar is here. So this tension will be transferred in this column through this LD. You can see this. So this is the LD, development length. Both are same. Now let's see the reinforcement details for the slabs. So simply supported slab. So yeah, simply supported slabs, generally, let's say the consultant is giving the steel as T8 at 150 as the alternate bar bent up. So it will be, see this bar, you can see, then it is a bent and it is going straight at the end. Then again, you'll see this bar is straight and we are doing the bend here and then it is going like this. So alternate bar, because see this one bar is, so if I show the reinforcement, then it will be T8 at 300, this bar, and this bar is T8 at 300. So the total steel at the mid span will be T8 at 150. So this is the your T8 at 150 alternate bar bent up. And then these dots are nothing but distribution steel given as per given in the structural drawing. It may be, let's say, T8 at 200 or something, distribution steel. So these all dots are distribution steel. If it is a one-way slab, if this is a two-way slab, then these dots which are at the bottom, they are also main steel, which is alternate bar bent up. So it depends what kind of slab detail is there. We will have a session on the schedule of beams and slabs also, and we will correlate with this drawing also in some upcoming session. Plus, in this session, please try to understand how the detailing is done, and the distance of this bent up location is L1 by 7 here. So we are starting here from L by 7, again here L by 7, and the L1 distance is nothing but clear span between the beams. So this is the slab detail, simply supported. Then there is a continuous slab. So here details are same as it is a simply supported end, or we can say end location of the support. It is L by 7, but when it is a mid support like this mid beam, L1 upon 5, and here L2 upon 5. L1 is for this beam or for this slab span. L2 is the span of this right slab. And top over bent up extra support bar. So this bent has to go like this in this slab, which is L by 4 and again L by 4. Corresponding L by 4 means as it is L1, it will be L1 by 4. As it is L2, it is L2 by 4. So this bend will go like this. And the bend will start here from L1 upon 5 here, as this is a mid support. This is an end support. So it will be L1 by 7. So please keep in mind, For these bars, there is no problem because they are L1/4, L1/4. There is no problem. So this is the continuous slab detail. Again, these dots are distribution steel if it is a one-way continuous slab. And if it is a two-way continuous slab, then these dots are also main steel, alternate bar bent up. Now let's see the cantilever slab detail. So it is similar to beams only, but regarding the span. So this, let's say this is your main steel for bar, main steel. So this main steel is something like this. Okay, you can see. Even at the compression zone also we are putting the steel. And this top bar is going in the back beam for distance L. So this is the L and this is the L. So it can be L or LD, whichever is maximum. So this is the cantilever slab detail. Generally, we provide the steel at the compression zone also because there is a possibility of cracks here in this zone in future. Generally, cantilever slabs are exposed to the weather like balconies or terraces. So in that case, we need to provide this steel. And these dots are nothing but distribution steel as per given in the structural drawing. So this is the cantilever slab detail. Development length, we have seen that. So generally it is in multiple of the diameter of the bar, 60 times diameter, or if it is a M25 grade of concrete and Fe500 steel, 50 times diameter of bar, 50D. See, so this has to be checked carefully in the drawing because it depends on the grade of concrete. So see, generally site people may think that only 50 times diameter is okay. But nowadays, as we are using the higher grade of steel, you should have more lap length and development length. So check it in the drawing. So don't do it blindly. Now, these are the structural notes which are given in the structural drawing. So all dimensions are in millimeter unless noted. So this is also important. So if you see this, whatever dimensions, now it is a general drawings, but in real drawing of the practical project, this L1 may be given in the drawing, which may be, let's say, 4 meters. So they will not give the 4 meter. They will write here as 4000 mm. So whatever dimensions are given on the drawing, they are in millimeters mostly. And levels generally are given in the meters. Now it is mentioned what codes are used for the reinforcement and concrete design. So it is IS 456. Okay. Then for steel reinforcement, what codes are used for HYSD? These HYSD bars are used for the structural drawing for this project, and minimum diameter of the bar considered is 8 mm. So nowadays generally 8 mm is used, minimum steel. For earthquake ductility detailing, IS 13920 is the code. Then yes. So generally, if site mix is done, then the grade of concrete is M20 generally used. And if you are using higher grades, then you should do the mix design from the laboratories, or you can use the RMC concrete for the project. For M20 grade, generally people are using site mix. And in that case, you should use minimum 20 mm aggregate size, and cement content should be minimum 300 kg per meter cube as per IS 456, and minimum water cement ratio 0.5. So all these things are given in this structural notes. And yes, properly it should be vibrated. Concrete has to be vibrated properly. Lap length should be minimum 60 times diameter of the smallest bar. And yes, there is one more point. The lap shall be away from the beam junctions. So this lap is something different. See why I am saying this. So this lap length, see sometimes what happens, we use let's say this is a column, this is a beam. So if you are using any lap, so let's say bottom bar, I want to lap this. So I will lap this. in the L/3 zone. Okay. See, my length of the bar is now terminating over here. So I want to do the lap here. So this lap location has to be at least L/3 from this zone support. So if this is a L, then the lap location is L/3. At every here also it will be L/3. If you want to provide any lap in the beams, provide at a distance L/3. So like this. Okay. Why we provide this at L/3? Because generally the point of contraflexure, this point, point of contraflexure means where the bending moment is 0. So it is generally L/3, roughly, we can say. You can see here 0.25 L1, which is near to 0.3 L1, which is L/3. That's why the lap has to be near the L/3 location. Don't provide the lap at the center because there is a maximum moment at the center. Or here also you can see. And even maximum moment is at the support also. Don't provide exactly at the support or exactly at the midspan. It should be somewhere here, L/3 location. So that note is given here. Then yes, at any junction, the lapping should be maximum 50%. So for example, let's say you are having 4 bars at bottom, let's say 4 T12. So you should lap only 2 T12 at one location. And at other location, you should provide 2 T12. So that is the 50% lapping at any location. It should be staggered, we can say. And there are cover requirements given. So for column, it is 40 mm generally, then footing 50 mm, or it may be 75 mm if it is in coastal region. In that case, generally footing cover is 75, but you should follow the structural drawings. Slab, it is 20 mm to 25 mm, and for beams, it is 25 to 30 mm. For this project, it is a 20 mm for slab, 25 mm for beams. For footing, it is 50, and for column, it is 40. So generally, these are the cover requirements. If you are working on the side, then follow this using cover blocks. And if you are a structural engineer, then for design of beams, columns, footings, use these covers while calculation of the D effective. Okay, so this is the criteria. See, it is written here, cover block shall be used to maintain the proper cover. Yeah, then work shall be carried out under supervision of qualified and experienced civil engineer. So this is very important, and it has to be followed as per structural drawings, because all of you know that as all structural drawings are important because it is a safety of the project or safety of the building. And if you provide the proper reinforcement detailing, concrete grades, and follow the quality procedures on site as per structural drawings, then structure becomes safe. Therefore, it has to be very much important to have a qualified civil engineer on site. And these are the details given for the de-shuttering period. So whenever we do the concreting, we remove the shuttering or formwork to reuse it for the other slab or other beams. So for columns, walls, see, this is not beams. For columns and walls, it should be 24 hours vertical formwork de-shuttering period. Then for props to slabs, up to 4.5 meters, 7 days. So after 7 days, you can remove if your slab is till 4.5 mm, 4.5 meters, sorry. And then props of the slab. See, if the slab span is more than 4.5 meters, then 14 days should be the de-shuttering period. For the beams till 6 meter span, you can remove the props after 14 days. And if the beam span is more than 6 meters, then you should remove the props after 21 days. So this is the general criteria for de-shuttering, and it is given in the IS 456. So these are overall structural notes, development length, and details of the slabs and beams. So I hope all of you have understood all these things as a site engineer and as a structural engineer also. Now, how to use and refer the structural drawings. This is a standard drawing, and we will also refer the schedule of beams and slabs. and how to correlate that we will see in upcoming sessions. So thank you all for listening my session. Let's meet on the next session. Thank you.